Welcome to this lesson on proportional relationships, tables, and equations. Today we're going to talk about discovering proportional relationships, identifying proportional relationships, and writing an equation for a proportional relationship. The essential question for today is how can you use tables and equations to identify and describe proportional relationships? As always, we'll start with vocabulary. So a proportional relationship is a relationship between two quantities in which the ratio of one quantity to the other quantity is constant. So what this means is if I have a ratio of $5 to 3 juice boxes, so for $5 I get 3 juice boxes. And for $10 I get 6 juice boxes. If I break these down and figure out how much it costs me per juice box. In this case, I know it breaks down into $1.67 per one juice box. If it is the same for both ratios, that means that the ratios are proportional. Taking that one step further to the constant of proportionality, if the relationship between x and y is a proportional relationship, then the equation for the relationship may be written as y equals a times x, where a is a positive number and is the constant of proportionality. So what this means is I can use the constant of proportionality to help me find my other ratios. So in this case, y, the cost, would be found by doing $1.67 times x, the number of juice boxes I purchase. Remember, the word constant means that it doesn't change. So I know that paying $1.67 per juice box is not going to change. That ratio should not change unless for some reason the juice boxes were to go on sale. However, on a day-to-day basis, if they are $1.67 a piece, then if I plug in for X the number of juice boxes that I buy, I should be able to get Y, how much it costed. All right, so finding proportional relationships. So a giant tortoise moves at a slow but steady pace. It takes the giant tortoise 3 seconds to travel 10.5 inches. We're going to use the bar diagram to help determine how many inches a tortoise travels in 1 second. So it's important to read carefully here. They want to know how many inches in 1 second. The reason that this is important is because it tells us how to set up our ratio. So in this case, it wants to know inches in or per second. Well, I have the information here of 10.5 inches per in 3 seconds. So now what I want to do is I know how fast and how far he goes in 3 seconds. I want to know how far he goes in just 1 second. In order to do that, okay, so I'm finding the unit rate. In order to do that, I need to get my denominator down to 1, which means I need to divide the top and the bottom by 3. I would get 3.5 inches on top to 1 second on bottom. So I know that in 1 second he can travel 3.5 inches. Okay, what operation do we use here to find our answer? In this case, we use division. All right, so now we're going to fill out the table. We're going to use the unit rate that we just found, so the 3.5 inches in 1 second, to help us fill out the table. Well, I know for a fact that from the problem, in 3 seconds he goes 10.5 inches. Now we have to be careful because the table has time on top and distance on bottom. However, they want in the ratio distance to time. So you have to be careful, make sure you put your numbers in the correct place. So in the table I have my 3 seconds and the 10.5 inches that he walked. My ratio is 10.5 to 3. So I know that he goes 3.5 inches in 1 second. I can also bring that down here because I've already figured it out. Okay. I know that in 1 second he goes 3.5 inches. So now I've taken and broken down that ratio and gotten the same here and here. So right now I can look at it and see that they are proportional, but let's continue to look at the other numbers. So in 2 seconds, we want to figure out how far the tortoise went. Well, I know that all I have to do is if in 1 second he goes 3.5 inches, then in 2 seconds he should be able to go twice that far because it's twice as much time. I multiply that by 2 and I get 7 inches. So he goes 7 inches in 2 seconds. Again, still gives us a breakdown of 3.5 inches in 1 second. For 4, I would multiply 4 times 3.5, and I would get 14. So in 14 seconds, to go 14 inches, it takes him 4 seconds. Again, if I break that down, I get 3.5 inches in 1 second. Okay, to find out how far he goes in 5 seconds, I do 5 times 3.5. I get 17.5. So to go 17.5 inches, it takes him 5 seconds. If I break that down, again, it breaks down to 3.5 inches in 1 second. So what do you notice about the ratios? You should notice that all the ratios break down to the same ratio. They all break down to the 3.5 inches in 1 second. Because they do this, I can determine that all of these ratios are proportional. So your reflection question. Conjecture, how do you think the distance a tortoise travels is related to the time? So a conjecture is a prediction, and you want to predict how the distance a tortoise travels is related to the time. All right, identifying proportional relationships. So back here, we discovered them, we put them together, we figured them out. Here, we're going to identify them. We're going to decide if they're proportional or not. So Alberto types 45 words per minute. Is the relationship between the number of words and the number of minutes a proportional relationship? Why or why not? So the first thing that we need to do, remember a proportional relationship, the comparison between the two always has to be the same. So first we have to complete the table. So I know that in 1 minute he types 45 words. So then in 2 minutes he should be able to type twice as many words. It's twice the amount of time, twice the amount of words. So this should be 90. In 3 times the amount of time, he should be able to write 135. Okay, because 1 times 3 is 3, so I have to do 45 times 3. In 4 times the amount of time, he should be able to write 160. I apologize, that should be 180. And in 5 minutes, he should be able to write 205 words. So now we need to determine if these are proportional or not. So what we're going to do is we are going to use the values in the table to complete the ratios. Okay, so in this case, we fill out our ratios. They're 90 to 2, 135 to 3, 180 to 4, and 225 to 45. And I apologize back here, I missed carrying the 2. This should be 225, not just 205. All right, so because all of these break down, we know that the common ratio is 45 to 1. So 45 words to 1 minute. So since they all break down to the same ratio, we can say that the relationship is proportional. All right, so let's take a look at the next problem. So the table shows the distance Allison drove on one day of her vacation. Is the relationship between the distance and the time a proportional relationship? Why or why not? Okay, so we used a table to determine whether or not they were proportional by using the table to break down the ratios essentially to their unit rates to see if they all had the same unit rate. All right, so let's try that again. So in this case, we have 1 to 65. Well, 2 to 120. So if I break that down, if I divide it by 2 and divide it by 2, here I get 1 to 60. Well, this and this are not the same. This is 1 to 65 and this is 1 to 60. Let's double check with the 3. So I have 3 to 195. In order to get the 3 hours down to 1 hour, I would have to divide by 3. And what I do to the top, I do to the bottom, so I get 1. 3 goes into 19, 6 times. 3 goes into 15, 5 times. So I get 1 to 65. Okay, so let's try 4 to 220. So I know I have to divide both of them by 4. And I get 1, 2, 4 goes into 22, 5 times. Okay. And 4 goes into 20, 5 times. So I get 1 to 55. Okay, so I have 3 different breakdowns here. I have 1 to 60, 1 to 65, and 1 to 55. Since these do not have the same constant, they do not have the same unit rate that they break down to, we can determine that they are not proportional because they do not share the same constant. Okay, and your reflection question. Do you think Allison drove at a constant speed for the entire trip? Why or why not? So use the information in the table and your answer here to determine if she drove at a constant speed. Remember, constant means it didn't change. All right, so writing an equation for a proportional relationship. So now this is when we know that the relationships are proportional, and now we're going to use that table to write an equation. So 2 pounds of cashews cost $5. 3 pounds of cashews cost $7.50. And 8 pounds of cashews cost $20. Show that the relationship between the number of pounds of cashews and the cost is a proportional relationship. Then write an equation for the relationship. So in order to determine if it is a proportional relationship, again, we have to see if they have the same constant. So we have to find that breakdown. So we know that if we buy 2 pounds, it costs $5. If we buy 3 pounds, it costs $7.50. And if we buy 8 pounds, it costs $20. Okay, so now what we're going to do is we're going to complete the ratio. So we have 3 to 750. and $8 to $20. So now we're going to see if those breakdowns all equal the same constant. So 5 divided by 2 gives me 2.5. Okay, so this means that for every 1 pound that I buy, it's going to cost me $2.50. If I break down the 3, let's see what that becomes. So I have my 3 divided by, I apologize, I put these in backwards. This is why you always want to go back and double check your work. So here, it's the cost on top, so $7.50 gets you 3 pounds, and $20 gets you 8 pounds. That's why it's always important to go back and check your work and to read carefully when you're putting together your proportion. So we have $7.50 divided by 3. Again, breaks it down to 2.5. And 20 divided by 8, which again breaks down to 2.5. So we have determined that they all have the same constant of 2.5. So the cost is always 2.5 times the amount of pounds that you buy. So we have determined that the common ratio is 2.5, and that therefore this is a proportional relationship. So now that we know that the relationship is proportional, and since I know that the common ratio was 2.5, okay, I have to figure out what each piece of the equation is going to represent. So x is going to represent the amount of cashews, because remember, the equation is written as y equals a times x, where a has to be the constant of proportionality. So I know that a is going to be my 2.5, because that's my constant. That doesn't change. And we saw that it didn't change when we made our table and figured out that the breakdown is always 2.5. So because this doesn't change, it is the constant. So x is going to represent the number of pounds of cashews. Y is going to represent the cost in dollars. And then we're going to use the common ratio, the constant, as the constant of proportionality. So the equation of the relationship would be, well, if we want to find our answer, it would be y equals 2.5 times x. Okay. So y, the cost, is equal to 2.5 times the amount of cashews you buy. It's important to tell what each variable represents, because if you don't and you plug in your numbers in the wrong spot, so let's say I put the cost here and the cashews here, my answer would not come out right. For example, if I did y equals 2.5 times x and I put in $7.50 here times 2.5 and then put my 3 here, I would find out that it does not equal out. It doesn't work. So 2.5 times 750 does not give me 3. But if I put my numbers in the correct spot, so based on what I said about the variables, that x is the number of pounds of cashews, so 2.5 times 3 is equal to 750. Now I can double check. 2.5 times 3 is equal to 750. So what you always have to do is you have to break down your ratio to its unit rate and see if they all have the same unit rates. If they do, they're proportional. That unit rate is the constant of proportionality. That's what you can multiply your number by to get your answer. So in this case, we multiplied the number of pounds of cashews times that constant to get our price. And you always have to double check the order, because if you have the order incorrect, that's going to mess with your results a little bit. Okay, so how could you use tables and equations to identify and describe proportional relationships? So remember, we talked about how to use tables. Okay, how do we use those to break down the proportions? And then how can we describe proportional relationships? So how can equations describe proportional relationships? What do they give us to help us find new ratios for our proportions?